This is the video on section 10-5 for factoring polynomials. The essential question is, how do you use the factor theorem to determine factors of a polynomial, and how do you factor the sum and differences of two cubes? The remainder theorem states that if a polynomial is divided by x minus a, the remainder is the value of the function at a. So if x minus a is a factor of p of x, then p of a has to equal 0. So for example, reading the theorem for any polynomial p of x, that x minus a is a factor of p of x, if and only if the value at a is 0. So for example, because the value at 1 of 1 squared minus 1 equals 0, then I can say that x minus 1 is a factor of the polynomial x squared minus 1. So, for example, it says, determine whether the given binomial is a factor of the polynomial p of x. So we want to know, is x minus 1 a factor of x squared minus 3x plus 1? So what we're going to do here is we're going to use synthetic division. So we're going to actually have -1, because this is in the form of x minus a, so a is really a negative in order to change that to a positive. If I look at my coefficients, I have a 1, a -3, and a 1. Bring down my 1. 1 times -1 is -1. -3 and -1 make -4. -4 times 1 is +4. And 1 plus 4 is 5. So in this case, we can say that x plus 1 is not a factor of x squared minus 3x plus 1, because the value at -1 does not equal 0. Let's try another. So in this case, the number we're going to use in our little box for synthetic division would be -2. Our coefficients would be 3, 6. There is no x squared, so 0, -5, -10. Carry down my 3. That gives me -6. Add these together, I get 0. Multiply, I get 0. Add, I get 0. 0 times -2 is 0. That's -5. -5 times -2 is +10. And when I add these together, I get 0. So in this case, we can say that x plus 2 is a factor of 3x to the 4th plus 6x to the 3rd minus 5x minus 10, because the value at -2 is 0. Okay, let's review some factoring. First thing you always want to do with any factoring problem is to look and see, is there a greatest common factor? So is there a number or variable that 3x to the 3rd minus 6x squared negative 27x and positive 54 can all be divided by? And in this case, we can say that we can pull out a 3. So that leaves me with x to the 3rd minus 2x squared minus 9x plus 18. Okay, then there's 4 terms here, so we can use something that you may be familiar with called factoring by grouping. So I'm going to put parentheses around the first 2 and parentheses around the last 2. What can be factored from x to the 3rd and -2x squared? And I'm going to go ahead and carry down my 3 so I don't leave it off my answer. So what can be pulled out from here would be x squared. X squared times what is x to the third, and that would be x. X squared times what is negative 2x squared, and that would be negative 2. Then what can be pulled out between negative 9x and positive 18, and that would be negative 9. That leaves me with x, and negative 9 times 2 would be, oh, we need a positive 18, not a negative 18, so this is minus 2. So negative 9 times negative 2 is positive 18. And that should happen because whatever is left in these parentheses that I'm underlining right here should be the same. So right now, what my answer looks like is you have the 3 out front, take what's the same, in this case is x minus 2, and then you have the outside numbers that you're going to write together as one factor. And before you say this is your final answer, you need to look and ask yourself, can x minus 2 be factored any further? Can x squared minus 9 be factored any further? And the answer is yes, because this is the difference of squares. So I'm going to go ahead and bring down what I know is already factors so I don't forget them off my answer. And then the difference of squares, square root of x squared is x, square root of 9 is 3. And one's a positive and one's a negative. And now you're done. Just as we have special rules for factoring the difference of two squares, there's also special rules for factoring the sum or differences of two cubes. Now, we've talked about one of these before, but now we're going to put them both together. The sum of two cubes factors to, the first thing you're going to do is take the cubic root of the first number and the cubic root of the last number. That's where the a and the b comes from. And if you notice, if it's the sum, that means there's a plus sign between the two terms originally. In the first set of parentheses, there's a plus sign, but in the second set of parentheses, you have a negative in the middle and a positive on the end. Where in the difference, that means there's going to be a minus between the two perfect cubes. In the first set of parentheses, you have the minus. Second set of parentheses, you have a plus followed by another plus. Now, an easy way to remember this is that the sign in the first set of parentheses for the binomial is going to be the same sign as whatever the original problem has. In the trinomial, this first set, or the first sign here, is going to be the opposite of whatever the sign was. If you notice, if it was a plus, now it's a minus. If it's a minus, now it's a plus. And the last one here is going to always be positive. So if you remember SOAP, and that's the term you're probably hear, if you're in my class, you'll hear me say it, or Miss Brigman's class, she'll probably say it as well. So SOAP is an easy way to remember what the signs are supposed to be. Now let's put this into use so you can actually see what it looks like. So factoring completely, first thing we're going to do, always look for a greatest common factor. So does 4 and 108 have something in common? In that case, the answer is yes. You can pull out a 4. X to the fourth and x, you can pull out an x. 4x times x to the third is 4x to the fourth. And 4x times 27 is 108x. Okay, so before you say you're done, you have to look. Is x to the third a perfect cube? Is 27 a perfect cube? And the answer to that is yes. So you have to keep going. So in your head, the cubic root of x to the third would be x, and the cubic root of 27 would be 3. So I'm going to carry down my 4x so I don't leave it off my answer. Since it's addition, I'm going to go ahead and put in my signs. So SOAP stands for the first one is the same. So since it was addition here, it's going to be addition here. Then the opposite, and then always positive. So it says take the first term, going to go here. The second term is going to go here. This one is going to be your first term squared, so x squared is just x squared. The term in the middle is just the product of these two, so x times 3 is just 3x. And then this one is your second term squared, so 3 squared is 9. And that's our answer. So number 4, we're going to ask ourselves, does 125 and 8 have anything in common? And the answer to that is no. And there's no other d over here, so I can't factor out a d. So my next question is are these perfect cubes? And the answer to that is yes. So the cubic root of 125d to the third is 5d. And the cubic root of 8 is 2. So our parentheses, and the first one it's the same, so since it's a negative here, it's a negative here. Opposite, always positive. So first term goes in front. Second term. First term squared, so 5d squared. 5 squared is 25, and then d squared. Then you're going to multiply these, so 5d times 2 would be 10d. And then your second term squared, so 2 squared is 4. One more. Is there anything common between 8 and z to the 6th? And our answer there is no. So I'm going to ask myself, is 8 a perfect cube? And the answer to that is yes. The cubic root of 8 is 2. The cubic root of z to the 6th would be z squared. So when I set up my parentheses, I'm going to move this down so I have a little bit more room. The sign here is a positive, so the first one's going to be a positive. Opposite, always positive. So first term is 2. The second term is z squared. 2 squared is 4. 2 times z squared is 2z squared. And z squared squared, so in other words, z squared squared, would be z to the 4th. Last example says that the volume of a plastic storage box is modeled by the function v of x equals x to the third plus 6x squared plus 3x minus 10. Identify the values of x for which the value of v of x is 0. Then use the graph to factor v of x. So first thing we would do is in our graphing calculator, you would type in your function in y equals so that you get the graph that you're seeing right here. That's your first step. Second step is to pick one of the zeros and then use synthetic division to factor the polynomial. So if you look at your graph, the first 0 that I notice is right here, which is at x equals -5. So I'm going to use synthetic division. And our coefficients are 1, 6, 3, and -10. Carry down my 1. 1 times -5 is -5. Add those together, you get 1. Multiply, you get -5. Add those together, you get -2. -2 times -5 is +10. Add this together, you get 0. So as it stands right now, since x equals -5 is a 0, that tells me that x plus 5 is a factor. And then since I started with x to the third, this is now x squared. So that's going to be x squared plus x minus 2. But this can be factored further, and you can either pick another 0. So like you could pick -2 or even +1 and use synthetic division with these, or just factor this as normal. So that's going to be x plus 5 Two numbers that multiply to be -2 and add to be 1 would be +2 and -1. And then it's completely factored. Also, just kind of give you a heads up here. If you notice that your highest degree on this equation was a 3, we have 3 zeros right here. So that's one way to check and make sure that you're seeing all of your graph. Now, some of your zeros may repeat, like when you factor it, you may get x plus 2 and x plus 2, but you would still have 3 factors, which would all give you zeros. But it's okay for a 0 to be the same number repeated. We'll talk more about that in class tomorrow.